Good morning to all. Myself Dr. K. Manogaran, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about stepper motor. So if you have an AC motor or DC motor, it can perform an rotations. So once if you energize it, it start rotating. So if you take a motor, it can rotate in forward direction and reverse direction. But that is not sufficient for a movement of particular angles. Because once if we energize, it starts rotating, so we cannot move particular angles. So that's why we go for a stepper motor. So in stepper motor, once if we energizes, it moves only a one particular step angle. So depending upon the construction, the stepper motor step angles will be decided. So the multiples of step angle movement will be possible in stepper motors. So it translates this electrical pulse into mechanical movements. So here this will be useful in many applications like printers and other robotics and all other places. Whenever we require some particular angle movement, the stepper motor will be useful. So the main advantages is the particular position control will be possible in the stepper motors. So it have two things, one is stator and another one is rotor. So stator that will be stable and then rotor that will be have a rotation. So for rotor they use a permanent magnet. The stator we use an electromagnet. So these electromagnets to be energized to form a particular movements. So we need to have a movement for the forward direction or a reverse direction. Also any particular angles. So that will be decided with the stepper motors. Look at this, the arrangement of stepper motors. So this is the rotor. We have a permanent magnets. That's why they mention it as N and S. So that are poles, north pole and south poles. Look at this. These fours are electromagnets. So these will be connected with this supply voltage. So depending upon the energizing schemes, so it have a movements. Look at this. So the important parameters for the stepper motor is, first one is step angle. So this is the minimum angle that moves in a stepper motor when one particular pulse is applied. So the stepper motor can rotate only the multiples of step angle. For example, the step angle is 10 degree. The multiples of 10 degree only possible by using this particular stepper motor. So once if we energize, it moves for 10 degree. If we energize another time, it moves another 10 degree. So total degree will be 20. So if you energize for 10 times, so 10 into 10, the 100 degree movement will be possible. So step angle if is higher, so we get only a minimum possible angles. For example, I am using the step angle 10 degree. If I try to move for a 5 degree or 2 degree, that is not possible. But in other hand, if the step angle is very less, for example, step angle is 1 degree, there is possible of movement of all 360 degrees. So multiples of all 1 values. The problem is it requires more cycles to reach the particular angle. For example, if I need to move for 30 degree, if the step angle is 10 degree, so within 3 pulse energizing, I get a 30 degree. For example, the step angle is 1 degree, what happens? It requires 30 times energizing to reach that particular 30 degrees. So depending upon application, we can choose the step angle. The step angle depends on the construction of the stepper motor. Next one is the steps per revolution. So this is number of steps required to reach the one complete rotations. So now one complete rotation, it requires a 360 degree. So 360 degree divided by step angle, that gives the steps per revolution. So this is the number of cycles required to reach a complete rotations. Next will be steps per second. So steps per second is nothing but number of steps we can energize in a particular second. This is the steps per second. Next will be RPM. So this is revolution per minute. So how many rotation will be possible in 1 minute, not second. This is revolution per minute. So number of revolutions per minute that we are taking. So how many rotations that will be completed in 1 minute. So that will be taken as an RPM. So another possible is we can take RPS, that is revolution per second. So how many rotation possible in 1 second. So this is the important parameters required for an understanding the stepper motors. So here we use different energizing scheme to energize the motors. So depending upon the requirements. So we can use a higher torque or a low torques, and then we can use a soft method or full methods. Look at this. So this is wave drive mode method of energizing. So here we have a 4 windings. So each windings will be energized one by one. Look at this. So this is the steps. First step, I am energizing a winding A and then de-energized with the winding B, C, D, E. And then second step, I am energizing a winding B and remaining windings will be off. Look at this third step, I am energizing a wind C and then remaining windings are 10 off. Look at this fourth step, I am energizing with the winding D. Look at this, all the 4 steps, at a time only one coil will be energized, remaining all coils will be de-energized. So in this mode, only one coil will be energized at a time. And then, so it gives low torque because only one coil will be energized, it have a pulling power will be less. So, but still it will be have an applications again. So this is, look at this, this is step 1, 2, 3, 4. So if we go with this incrementing order of step angle, what happens? It will be moves in a forward direction. Some cases I required a reverse direction movements. There I need to energize first with the fourth step. This is winding D is energized. After that third step. After that second step. After that first step. It gives the same step angle movement with anti-clockwise direction. So whether you want a clockwise direction or anti-clockwise direction, that sequence of data has to be energized. Again, the energizing schemes, for example, if you energize it 1, 2, 3, 4, after that again we need to energize 1, 2, 3, 4 to reach a next step angle forward direction. So these procedures will be repeated till that particular angle will be reached. So this is the first mode of driving the stepper motor. Now look at the second mode. This is a full drive mode. Here 2 coil will be energized at a time. So here look at this first step, winding A and B is energized. Next step, look at this, winding B and C is energized. Look at this third step, winding C and D will be energized. Look at this fourth step, look, winding A and winding D will be energized. So here at a time 2 coils will be energized. What happens? It have a higher torques and it should have a proper procedure to energize it. For example, look at this first thing, we have energized winding A and B. Next step, we cannot energize a new coils, 2 new coils. Look at this, I am holding this winding B. Instead of A, I am changing to C. Similarly, look at this step 2 to step 3 changes. So step 3, I am holding this things, winding C, so same value. And then instead of winding B, I am changing to winding D. Similarly, look at this third step and fourth step. What happened? So third step, we have C and D is energized. What I am doing, this D coil will be kept same value. So look at this. Instead of C, I am changing to A. So the energization scheme must be in the sequence. Only one coil will be changed for a next sequences. So if we energize with this 1, 2, 3, 4 order, it gives a clockwise direction. Instead of this, if you do with reverse, that is, for example, if you energize with fourth, then third, and then 2, then and 1, that is a reverse order, it gives anti-clockwise direction. Look at this, this is the half drive mode. So in half drive mode, so both methods will be combined. So what happens? It gives a better index. Look at this, it have 8 steps. Look at this, this is an 8 step. So the odd numbers, so it given a single coil energization. The even numbers we have an 2 coil energizing methods. So these two will be combined. Look at this. First we have an only winding A is energized. Look at this step 2. The winding A and B is energized. Look at this third step. Winding B is energized. Combine this. So 1, 3, 5, 7. So these have the single wind energizing. And look at this 2, 4, 6, 8. This have a 2 winding energization. So we are combining both things in this method. So we have energized 1 coil and then 2 coil. Again 1 coil and 2 coil. This will be repeated for the methods. Look at the circuit diagram. We have this 8051 microcontroller. Port 1 will be taken and that will be connected to the driver IC. From this we connecting a stepper motor. Look at this. So these 4 will be a windings and that will be connected. So depending upon the values, that corresponding value will be sent from microcontroller to the driver IC, that coils will be energized. Thank you.